So today I'm going to walk you through a couple of the gears practice problems and how you can determine gear ratios, and then also how you can gain information from gear ratios. So we're going to walk you through a couple of these problems to give you an idea of how to solve this. So first of all, you have a simple gear train. So a simple gear train means that all the gears are on different shafts, and you have gear A, driver, that has 6 teeth. You have gear B that has 18 teeth, and gear C that has 12 teeth. So it's to sketch and annotate the gear train described below. So as you can see, I have sketched and annotated the gear train. So gear A in this case is red, gear B is blue, and gear C is green. So if you want to do this yourself, all you have to do is come up here, insert, and find any of the shapes that you want, in this case an oval or a circle, and then you can change the colors of each circle. Okay, so let's look at this. If the output is at C, what is the gear ratio? Okay, so remember, the gear ratio equals the number of teeth out divided by the number of teeth in. Okay, so we'll substitute and solve here. Alright, so GR equals, alright, my number of teeth out in this case is gear C, so that's 12. And my number of teeth in, I look up here, what's my driver gear? That's A. So my number of teeth in is 6 teeth. 12 divided by 6, my final answer, gear ratio equals 2 to 1. Okay, or if you just want to say 2, the 1 is assumed. Alright, so if gear A rotates at 50 RPM, how fast is gear C rotating? Alright, so here we're dealing with angular velocity, which is RPM. So again, we put in our formula for gear ratio. We already know what gear ratio is. We'll get to that in just a second. So gear ratio here is angular velocity in, okay, divided by angular velocity out. Remember, angular velocity, or RPMs, is the reverse of everything else when you're talking about gear ratio. So now I want to substitute and solve. So we already know what our gear ratio is. That's 2, okay, equals, right, my gear in tells us it's 50, okay, and so we want to know then gear out, or RPMs out. Alright, so if something is on the top, we want it to be on the bottom. So we're going to take our 50 and divide that by our gear ratio to get our answer for gear C. So in this case, W out 50 divided by 2 is going to be 25. Now, we need to look and see if our answer makes sense. Okay? So if we go back up here, does it make sense that a gear that is twice as small is going to rotate twice as fast? Well, yes, it does, okay, because we know that smaller gears are going to have higher RPMs. So our out gear, gear C, okay, looks like our model versus our in gear, gear A. Alright, question number 4. If the output torque at gear C is 250 foot-pounds, what is the input torque of gear A? Alright, so again, we go to our gear ratio. In this case, torque in divided by torque out. Okay? So, small t, if you really want to find the Greek letters, you can come over here to symbol and track those down, but the small t for torque works just fine. So we'll substitute and solve. So in this case, we still have our gear ratio of 2, and we are looking for torque in, okay, and we have our torque out of 250. So again, if that number is on the bottom, okay, we can multiply that, all right, and get that number on the top. So anyways, like I said, our 250 of the out gear times our gear ratio to get our in gear. So torque in this case is going to equal 500 foot-pounds. Okay, so that's how you do a simple gear train. Now, the good news is that all of these gear trains are going to work basically the same way. So the next problem asks you about compound gears. Okay, so the compound gear train is composed of 4 gears, A, B, C, and D. Gear A has 10 teeth meshed with Gear B. Gear B has 20 teeth and shares a shaft with Gear C that has 15 or 16 teeth. Gear C is meshed with Gear D, the output gear. So again, you have 4 gears this time, but 2 of them are on the same shaft. So you would use your different color circles to draw those and to put those teeth in for question 5. Okay? Then the necessary torque output for the entire system is 1,000 foot-pounds. So we're going to back that out once we determine what the gear ratio of the system should be. So if I have 1,000 foot-pounds out, I have 200 foot-pounds in. Okay, that becomes an easy division there to solve that. So going down a bit further, this asks you how many teeth. So again, you're going to take that from here up top using your gear ratio and the information that you're given. So you have Gear B having 20 teeth, Gear C having 16, Gear A having 10, and they're asking you for Gear D. Okay, pulleys and belts. Again, similar. Okay, this time you have 3 pulleys. All right. Pay attention to where the driver is as you answer the questions. And then down here, lastly, you have chains and sprockets. That is going to work similarly equation-wise with the gears. So that's how you do gear ratios.